Hello friends, it's MoNaCo here. This is like take 6 on this video. I'm trying to get it down below 10 minutes for you. So let's go quick here. Pause it whenever you have to so you can catch what I might have said. Rewind if you need to. So this unit is, this lesson is about conversion factors and dimensional analysis. I'm going to teach you how to convert grams to kilograms, kilograms to grams, so I guess back and forth, meters to centimeters, etc. There's a technique that I'm going to teach you about that today. So you're going to convert basic units, and I'm also going to teach you about dimensional analysis, which is this fraction solving problem. Our lead in here is why do we bother converting? Okay, why would I need to convert meters to kilometers? Or hours to minutes to seconds to nanoseconds? Why would I need to bother doing that? Well, the connection is kind of a connection that you can understand through the kitchen. Okay, if you're having a dinner party and you know that you're going to make teriyaki chicken, you have a recipe for an order for a plate of teriyaki chicken that might serve 4 people. It says that in the recipe. What if you are serving 20 people? Well, you have to convert and scale up your recipe and use different measurement tools so you can make a larger batch of food for that meal. So that is our connection. Why would we convert between units? Well, if you convert between units, then you can pick the right measuring tool. Instead of making a giant loaf of bread with just 1 cup and scooping it 1,000 times over, maybe you find that you only needed 4 bags of flour. Okay? So unit conversions are about finding the right tool to make your measurements. And you just have to be able to do your unit conversion. Conversion factors, this is where our notes begin, are a mathematical way that relates 2 units that measure the same type of quantity. We call these in mathematics an equality statement. One thing equals another thing. And I think everybody knows that a minute is 60 seconds, 1,000 grams is a kilogram, and 1 liter is 1,000 milliliters. Usually in our class, the most that you'll ever have to be converting between is milli to kilo in the base unit. So 3 or 6 decimal places is all you're really going to have to move the decimal when you're doing unit conversions in here. But you got to make sure that you move that decimal in the right direction if you're increasing or decreasing your measurement tool. And this, the following, is a great way to do it. Here's a trick. Kilo, hecto, deca, base unit, deci, centi, milli. Okay? This system allows you to pick a unit. So let's say you're given kilometers, and a question asks you how many meters. So if you're given 10 kilometers, how many steps do you move in order to get that back to the base unit? Well, if you're starting with kilo, you go 1, 2, 3 to get to your base unit. So you made 3 steps. 1, 2, 3 steps. Well, you take the decimal place that you had and you move 3 steps to the right in this case. You move your decimal place 3 steps to the right. 1, 2, 3. So in this scenario, 10 kilometers is equal to 10,000 meters. Pretty simple. Okay. Other scenarios you might be asked, okay, how many liters are in 75 milliliters? Well, if you're starting with 75 milliliters and you're asked how many liters, well, 1, 2, 3 steps. But this time you're going to take your decimal place and move it back to the left. So it's a lot like scientific notation in that you're moving the decimal place around. Okay, so that's what you're going to learn about in this next couple practice problems here. There's a couple mnemonic devices to help you remember those, but I think it's just you got to really remember what you're doing, not necessarily the tricks. Okay, so I put the trick up the top to help us remember, and I'll give you 2 examples of each. 2 examples of a large number becoming a larger number, and 2 examples of a large number becoming a smaller number. So for example, 845 kilometers, how many meters is this? Well, we're starting here at the kilo with 845, and we're going to end here at the base unit for meters. We would see here that we want 1, 2, 3 steps to the right. So we're going to take 845 and move the decimal place 3 steps to the right and replace the units with kilo with meters. Okay, put a nice box around it. We like to see that in our final answers. This next one, pretty simple one, we're going to be starting with liters and going to milliliters. So we're going to start here with 0.0290, and we're going to end here with milli. So you're going to go 1, 2, 3 steps to the right. You're going to take that decimal place. So you're going to end up with 29.0, and it's not liters anymore. It's milliliters as our final unit. So that was a scenario where we're moving the decimal place to the right. Both of those examples were. Let's try one where we're going to move it to the left. we're going to start in this number 3 here, 2,500 milliliters to liters. So ml, milli, that's where we're starting, ml. We're going to liters, which is our base unit. Our base units are liters, grams, liters of volume, grams, and meters. Okay, L, G, and M. So we start with 2,500 here, milli, and we got to go back to liters, 1, 2, 3 steps, but in the left direction. So this time we're going to be turning this into 2.5 liters as a result. Okay. Number 4, we're going to start with the base unit, grams, 3 grams, and convert it into kilograms. So we're going to start here with the number 3, and we're going to end up here at kilos. So we've got to move that decimal place 1, 2, 3 spots to the left, which basically means we're going to have 0.003 kilograms. In these last two, 10 and 11, you're just going to be doing a comparison. So basically you have to do the conversion of the units from grams to milligrams, centimeters to meters, and then decide which one is larger or if they are equal. Centimeters, 56 centimeters, is that larger or less, or larger or smaller than 6 meters, etc. So pause the video at this point to do this practice, because the next couple slides I'm going to show you how to do unit conversion using fractions. Okay, hopefully you have paused the video and taken the time to do those practice problems before you move on to dimensional analysis with me. In this case, we're going to be converting 6 centimeters to kilometers. And you might say, well, I'll just do it this. I'll start with centi and go all the way up to kilo. I'll be moving 1, 2, 3, 4, 5 decimal places to the left. And you'd be right. That's one way to do it. But I'm always about teaching you different ways to do things and get the same result. So starting here, we're going to write the term to be converted, a number and a unit. So we're going to write 6.0 cm. The next one, we're going to write the conversion formulas to see the reference tables. We got to go from centimeters to kilometers. Everybody knows 100 centimeters equals 1 meter, and 1,000 meters equals 1 kilometer. Okay, so we're going to use both of those conversion factors. And we got to make a setup with the fractions so that we are going to cancel our units. So in step number 3, it says make a fraction of the conversion formula so that the denominator are the same as the units from step 1. So we're going to start with this first one. We're going to convert centimeters to meters, and then we're going to go meters, kilometers. So I'm going to start by here. 6.0 cm multiplied by 1 meter over 100 cm. You can see in this way that the centimeters are going to end up canceling. Okay, and this is going to end up with the units that we want to convert to, at least the intermediate step. There would be another fraction on here where we'd multiply by 1 km over 1,000 m, and the meters then would result in a cancellation, leaving us with the final units of km. And the math that you would do is you take 6 divided by 100 and divide that by 1,000. So checking out the last few steps here, it says multiply the term in step 1 by the fractions from step 3, which is actually what I did, so I'll rewrite those again here for you. 6.0 cm times 1 meter over 100 cms times 1 kilometer over 1,000 meters. Okay, cancel out the like units. So as we go down here, we're going to get 6.0 cm times 1 over 100 times 1 km over 1,000, because all the canceled like units disappear, leaving us again with the only units that we are caring about, which is km. Now solve everything. In this case, you're going to do 6 times 1 100th, or 6 divided by 100, times 1 1,000th, divided by 1,000. And the result that you get is actually going to be the same as if you did it with the other method. You're going to start by there. You're going to move the 1, 2, 3, 4, 5 decimal places to the right. So our final answer is going to be 0.12346 km would be our final answer there. That's a little convoluted, that long step. Let me show you this one more example to kind of drive it home. How many minutes are there in the month of October? Heck, how many minutes are there in an entire year? How many minutes are there in a decade? These are simple conversion factors that you are familiar with. If there's 31 days in October, you'll multiply that by the 24 hours over 1 day. Why? Because The days will then cancel, leaving you with hours. Then you'd multiply that by 60 minutes over 1 hour. Why? Because we're canceling hours and we want the final answer to be in minutes. This leaves us mathematically with 31 times 24 times 60. 31 times 24 times 60 units are in minutes. Okay? So there we are. There we have it. This is something that you have to practice in order to get it right. This video was not long enough to teach it to you all the way. You must practice it. So use that base 10 technique to convert between the simple units, and you can now use the dimensional analysis technique to convert between more complex units. So thanks for being with me there. We got a lot of practice to do in class. Have a good day.